Is my screen visible to all?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes,
Yes,
ma'am.
ma'am.
So, in the last lectures, we discussed about the 1D arrays and all the operations which are being performed on the 1D array. That was the traversal operation, it was insertion, deletion, searching, and sorting. So, C supports multi-dimensional arrays also. So, in 1D array, we used to write only the size of, or we can say the number of elements which we need to group together under a single name. In multi-dimensional arrays, you can have large number of values which can be written. Uh, if you talk about 2D array, so it will have rows and columns. In the same way that we use to draw graphs, so we use x-axis and y-axis. So x denotes the rows and y denotes the columns. In the similar manner, अगर हम 2D arrays की बात करते हैं, so the first column will denote the row and the second column will denote the column. Similarly, if we talk about 3D arrays, so it will be having x-axis, y-axis, and z. So the first will denote the rows, second will denote the column, and the last third will denote the z-axis. That is three dimensional. You will be able to view the values in three-dimensional form. C does not support more than supports multi-dimensional arrays, but for programming easyability, we use maximum up to three-dimensional arrays. 1D array that we have already taught, the 2D arrays and 3D arrays. Most of the programs which would be covered in our syllabus would be based on the 1D array that we have already discussed, and the second is your 2D array. So the simplest form of multi-dimensional array is your 2D array. The type would be the data type which we want to use, integer, float, character, or double. Then it would be followed by the array name. Any name you can give to the array, which should follow the nomenclature or as that of the naming used for the variables. There should be no special characters except the underscore symbol. The array name should not start with any numeric value. It should always be an alphabet. And then we will be providing the values for rows and columns in separate square brackets. The X denotes your number of rows, the Y denotes your number of columns. Here is the pictorial representation of your 2D arrays. See, as in 1D array, the indexing starts with 0 to n minus 1. Similarly, in case of two-dimensional arrays, or we can say matrices, we can start the index also from 0 and to the values of column. If the column number is denoted by y, so 0 to y minus 1, and the row numbering is denoted by x, so we will start from 0 to x minus 1. So if the array is of size 3 cross 3 cross 4, so the number of rows would be 0, 1, 2, and the columns would be 0 to 4, and each and every element would be represented by the values associated with the position. So the first element of the matrix would be at position 0, 0. The second element would be at position 0, comma 1. The third element would be at position 0, comma 2, and the fourth element would be at position 0, comma 3 for row number 0. Similarly, for row number 1, the first element would be at position 1, comma 0. Second would be at 1, comma 1, 1, comma 2, 1, comma 3. So the any of the operations which would be performed in a multidimensional array, or we can say simplest form of multidimensional array is a matrix. So we will have to go to each and every value by its position. If we want to process the values, we will have to reach that to that element using the index values. So we should be able to perform operations such as addition of matrices, subtraction of matrices, multiplication of matrices, finding the diagonal elements of a square matrix, and so on. So each and every operations which are being performed on a matrix can be implemented in C language using 2D arrays. Coming to initializing of two-dimensional arrays, so the arrays can be initialized statically as in case of 1D arrays. So we will have to mention the data type, the name of the array, followed by the number of rows and number of columns, and we have to group the elements row wise. So if the first row is having value 0, 1, 2, 3, so we will have to put these values in a curly bracket. Similarly, for row number 2, we will group the second row elements with within the curly brackets. And similarly, for the elements of the third row, we will group those elements in their own curly brackets. And finally, all these three rows values would be put inside the outer curly bracket. So the outer curly brackets denotes your matrix, and the inner curly brackets denotes the values which are to be inserted individually to each and every row. And if you do not want to use the nested brackets, you can directly write this. So the compiler would automatically divide these values depending on the number of columns. So if the column number is 4, so first 4 elements would be row number 1, the next 4 elements would be row number 2, and the last 4 elements would be row number 4. If you want to access two-dimensional array elements, so we can access these elements using their positions. So if you want to access the element which is belonging to row number 3 and column number 4, so uska representation would be a of 2 3, because we are giving the indexing as 0 to the n minus 1, the row number, and columns are represented by 0 to n minus 1. So this is a sample program which is showing how we can uh, initialize the array statically at the time of declaration, and then we are printing those values using the loops. So uh, for printing a matrix, we need nested loops. So since the syntax for loop is simpler as compared to while or do while loops, so we will be using the for loops for nesting or printing the values. So here array A is initialized at the time of declaration. I and j are your loop variables which would be used for printing the array elements. So this array is of size 5 comma 2. So there would be 5 rows and 2 columns. So the outermost loop will be denoting the loop for the number of rows. The nested loop, which is represented by the variable j, will denote the number of columns. So for printing each and every array values, we will have to go to each and every value by its position. So for the generalized statement for accessing the matrix element would be A of ij. So when the I value of I is 0, j loop will iterate from 0 to 1. So A of 0, 1 and 0, 0 would be printed. Next time when the I value is 1, so j would be iterating 2 times, 0 and 1. So 1, 0 and 1, 1 values would be printed. And this will be printing as in the form of matrix. So the first row will be having the value 0, 0. The second row will having value 1, comma 2. The third row will have value 2, comma 4. Similarly, the fourth row will be having value 3, comma 6. And the last row will have the value 4, comma 8. So here is the output. You can see the output that each and every element is printed by its position. So the first element is 0. It is having the position A of 0, 0. The second element is also 0. So it is having the position as 0, 1. तो आपको दिख रहा है यहाँ पे हमने स्टैटिकली इनिशियलाइज किया था. तो फर्स्ट रो वाज हैविंग वैल्यूज 0, 0. So the first two elements of the matrix are 0 and 0. So by this you can relate that each and every value can be processed or can be further operated using its index numbers. So let's come to an example for 2D arrays. So if I want to perform matrix addition, so all of you have studied in mathematics that for matrix addition or subtraction, the number of rows of the ऑपरेंड्स मस्ट बी इक्वल टू द नंबर ऑफ जो भी आप जिस पे भी वैल्यू स्टोर कर रहे हैं. ठीक है. सो इफ आई टेक द मैट्रिक्स एज 3, 3. Okay. So if this matrix is denoted by the value, so if I want to add these two matrix A and B, the first thing which we need to check is the number of rows of matrix A should be equal to the number of rows of matrix B, and similarly the number of columns of matrix A should be equal to the number of columns of matrix B. So if I say matrix A represented by M cross N, say if I am representing the rows and columns of matrix A by M cross N, so the matrix B should also have the number of rows and columns as M cross N. So the here M is denoting the number of rows and N is denoting the number of columns. So for addition or subtraction, these two matrices to be added must have this prerequisite conditions as that the rows and columns of matrix A and matrix B should be equal. And if I want to add these two matrices into a new matrix C, so that matrix C should also have the rows and column numbers as equal to that of A and B. That means addition, subtraction जो भी आपको operations perform करने हैं 2D arrays के लिए, that is commonly called as matrix. We should ensure that a matrix A and B should have equal number of columns, and if we want to store the values into another matrix after addition, so that resulting matrix should also have the same number of rows and columns. So if I am taking a 3 cross 3 matrix, so it is generally called as your square matrix because the rows and columns are equal. So if a matrix is having value 2, 4, 6, 8, 10, 12, 14, 16, 18. And matrix B is having value 1, 3, 5, 7, 9, 10, 13, 15, and 17. So after adding these two values of matrix A and B, the C would be the first element of the resulting matrix would be equal to the value which is obtained after adding the first element of matrix A, that is 2 plus 1, that is equal to 3. So C matrix would be the first element of the C matrix would be obtained after adding the first element of matrix A with the first element of matrix B. That means इसको अगर हम generalized form में लिखते हैं, तो इसको हम जनरलाइज फॉर्म में लिखना चाहे तो लिख सकते हैं A of 0, 0 plus
I mean, matrix B, these are just
B
random
of
numbers. Hello?
0, 0 is equal to C of 0, 0. So this expression would be same for each and every element of the matrix C. यानी कि first element would be at position 0, 0, So for calculating the first element of C matrix, we will uh, add the first element of matrix A with the first element of matrix B to obtain the first element of matrix C, that is 3. Similarly,
Yeah.
for the second element, we will add 4 plus 3 equal to 7. So this is your second element. Similarly, for third element, 6 plus 5 is equal to 11. So on, we can add the values. 8 plus 7 is equal to 3. 10 plus 9 is equal to 19. 12 plus 11 is equal to 23. 14 plus 13 is equal to 27. 16 plus 15 is equal to 31. 80 plus 17 is equal to 35. So the resulting matrix would be 3, 7, 11, 15, 19, 23, 27, 31, and 35. Okay. So if I want to write a program for such a logic, so the main logic would be, first I will be writing the loop for the row, that is I is equal to 0. I is less than the value m, since the rows are denoted by m and columns are denoted by n. I plus plus for j is equal to 0, j is less than n is denoting the number of columns, j plus plus. For addition part, we will be writing it as C of ij is equal to A of ij plus B of I. So we can say for addition, we will have to add the elements with same positions. So there is no change in the values of I and j. They are same for the resulting matrix C, and these are same for the matrices to be added, that is A and B. Okay. And then we will further close them. Similarly, in case of subtraction of matrices, is जहाँ जहाँ आपने plus operation perform किया है, we will replace this plus operation by subtraction. Okay, so 2 minus 1 would be 3. For addition, it was 2 plus 1. For subtraction, it is 2 minus 1. That is equal to 1. For subtraction of matrices, we will second for calculating the second element of resulting matrix, we will subtract 4 minus 3, that is equal to 1. Similarly, 6 minus 5 equal to 1. And so on for rest of the elements. 8 minus 7 is equal to 1. 10 minus 9 is also equal to 1. 12 minus 11 is equal to 1. 14 minus 30 is equal to 1. We have to keep in mind the order of matrices in the case of subtraction. If you are given that you have to subtract matrix B from matrix A, then this is the correct answer. But if it is given as that you have to subtract a matrix A from matrix B, then the result would be different. ओके एडिशन में ऑर्डर ऑफ मैट्रिक्स डज नॉट मैटर कि आप ए में बी को जोड़ रहे हैं या बी में ए को जोड़ रहे हैं बट इन केस ऑफ सब्ट्रैक्शन इफ द question is given as that you have to subtract a minus b matrix, So then you will have to put the element of A matrix at the first place as the first operand and the element of matrix B as the second operand. ये चीज आप ध्यान रखिएगा. So in the logic part, we will just replace the plus operation by the subtraction operation. So this loop is for, I am making it as red. The logic which is written in red color is the logic for addition of matrices, and the logic which is written in the black color is the logic for subtraction of matrices. Only the difference is in the operational part. For addition, we will be using the plus operator, and for subtraction, we will be using the subtraction operator, that is minus. So if we want to execute this code, so this is your assignment, that you will write a program. You will be writing a program for addition of matrices and subtraction of matrices. Okay. And this would be your assignment number 2.